All right, and this is section 2 of chapter 11 in the geometry curriculum. So I have a parallelogram. I designed this as a parallelogram. You can see as I drag the point, it remains a parallelogram. And what I'm going to do first is drop a perpendicular right here. Oops, that didn't work out so well. Let's escape on that. And I'm just going to have an intersection point where they met. And right now, the computer doesn't see that as a right triangle. I think you guys can see that, but I'm going to put a triangle there so the computer recognizes that as a triangle. So I'm taking this little triangle, which is a part of the parallelogram, and what I'm going to do is translate it. Translate means pick it up and move it over. So I'm going to take this triangle, and I'd like to move it over here. And you'll see that happen. Now let's focus on the new shape. Sorry, on the new shape. And you should see that is a rectangle. Now we already did the area of a rectangle was the base times the height. So hopefully you can see that's going to be the same as the area of our parallelogram. Because for any parallelogram, all you'd have to do is cut off this triangle, move it over to the other side, and it will make a rectangle. So the formula for the area of a parallelogram is also base times height. Now notice where the height is. It's not this side of the parallelogram. It's the perpendicular, just like it was in the rectangle. Now for the triangles, we're going to look at that. I have a triangle here. I'm going to drop a midpoint on one side. And we're going to hope this works because sometimes this doesn't work. And all I did was reflect it about the point. This new shape is a parallelogram. I can prove it. If you need help, I can show you how to do that, but I can prove it. And we already just learned the area of a parallelogram is base times height. But I don't want the area of the parallelogram. I want the area of the triangle. So what would I do to the area of the whole parallelogram to get the area of the triangle? Divide it by 2. So that's why the area of the triangle is 1/2 the base times the height. Right, so I have those here, some drawings here. Area of the parallelogram is base times height. The base can be any side, and the height is the perpendicular that corresponds to that side. The area of a triangle is 1/2 the base times height. Again, coming from any triangle with just a little rotation can be turned into a parallelogram. And again, the base can be any side. The height is the perpendicular drawn to that side. For the rhombus, you can use base times height since it is a type of parallelogram, but you can also use a formula that it says the area is equal to half the product of the diagonals. This basically comes from proving triangles congruent and doing the area of this triangle times the area of this one, and then adding those together, you will get this formula. So that's another formula for a rhombus that you can use. So over here, I have 2 examples. They're both parallelograms, so I'll tell you that. They're both parallelograms. And what I'd like you to do is push pause and work through these examples. All right, now the answers to these examples. I had to use what I knew about special right triangles to figure out the height. Since this is a 45-degree angle, the hypotenuse of 8, this side is a 4√2. So it's the base of 10 times the height of 4√2. Area was 40√2. Over here, again, I used special right triangles to find the height, which was 2√3. The entire base was 12, so 12 times 2√3 is 24√3. Okay, on this slide I have some more examples. Again, I'd like you to work through these. Push pause and work through these, then come back when you're ready to check. Okay, here I have your answers. Area of a triangle is half the base times the height. When it says the corresponding height, that just means the height that corresponds to this base, that goes to that base. The parallelogram is base times height, so you can see my work here. And for the rhombus, I use the formula 1/2 diagonal 1 times diagonal 2 is equal to the area. Okay, so we have 3 more problems here. I'd like you to work through these. Again, using what you can figure out, and then come back and check your answers. For the isosceles triangle, I drew an isosceles triangle. This doesn't have any special angles that I know of, so I used the Pythagorean theorem here to figure out what the height of the triangle was. And apparently I didn't solve this one. So the area of this triangle will be 1/2 the base, which was 10, that's where I drew the height to, times the height. And so your area is going to be 5 root 119. Okay, over here, I used this right triangle and the Pythagorean theorem to find out that this dotted line here is 4 root 2. And then the figure can be split into different ones. You can use this rectangle, that's where this part came from. And then I have two triangles, half of 8 times 8 and another half of 8 times 8. So your final answer is right here at 40 root 2 plus 64. Finally, the last question was an equilateral triangle, which means all the angles are 60. If this is 60 and the hypotenuse is 9, by special right triangles, I can figure out this length and the height. And then I use the area formula to determine that. Okay, so once you have that, check the website for the homework, and good luck.